Hi students, once again I welcome you all to my channel Abrar Sir Classes. Today we'll be seeing problems on topic field due to straight wire. Okay, this is the first problem. Magnetic field at point P, this is point P, due to finite length wire Ln is given, where I in ampere, I is given here and A in meter. Okay, is how much? This is a straight current carrying conductor of finite length. Okay, we have the formula. What is the formula for finding the magnetic field due to a straight current carrying conductor of finite length is given by mu naught by 4 pi into I divided by perpendicular distance. Okay, in general, right, perpendicular distance. Let us say R into what? Sine of alpha plus of sine of beta, where R is what? Perpendicular distance from point P to the straight current carrying conductor. Okay, in general. Now in place of R, what is given? A is given. Okay, R is equal to A here, right? What is alpha? Join these 2 points. This is alpha. Okay, what about these 2 points? Join these 2 points P and L. This is what? Beta. This is what? Beta. This is beta. Hope you understood. Okay, join N and P. Okay, and this is making an angle alpha. Join P and L, this is making an angle beta. Okay, now you have to find sine alpha and sine beta. Bp will be equal to what? Mu naught by 4 pi, I is given here, divided by what is the perpendicular distance? This is perpendicular distance, okay, between P and the straight current can conduct how much? A into what? Sine alpha plus of sine beta. What is sine alpha? Sine alpha is equal to opposite by hypotenuse, that is 3a by 4 is given, but you do not know Pn. How to calculate Pn? Pn can be calculated. The square on the hypotenuse is equal to sum of the squares on the other two sides. Okay, I can use Pythagoras theorem to calculate Pn. Pn is equal to what? Square root of, I'll just calculate here. Pn is equal to what? Square root of, okay, 3a by 4 the whole square plus of a the whole square, right? That is equal to square root of 9a square by 16 plus of a square, right? Pn is equal to square root of 16 denominator 9a square plus of 16a square. 16 plus 9 is 25. 5a by 4 will be getting. Okay, 5a by 4. Then what is sine alpha? Sine alpha is equal to perpendicular by hypotenuse, right? Okay, that is 3a by 4 divided by 4 by 5. 4 gets cancelled, a gets cancelled, you will be getting how much? 3 by 5. Similarly, you calculate PL. How to calculate PL? PL can be calculated, that is equal to square root of, okay, 4a by 3 the whole square. This is used by Pythagoras theorem. The square of the hypotenuse is equal to sum of the squares on the other two sides. 4a by 3 the whole square plus of a square. That is equal to, directly I will try to write 9, that is 16a square by 9 plus a square, right? That is equal to square root of 16 plus 10 is 25 a square. That is equal to how much? 5a by 3. That is equal to 5a by 3, right? Okay, how much is sine of beta? Sine beta is equal to opposite by hypotenuse, that is perpendicular by hypotenuse. How much you got PL? PL you got 5a by 3, right? 5a by 3. Sin beta is equal to perpendicular 4a by 3 divided by 5a by 3. This 3 will come in the numerator, divided by 5a. 3 gets cancelled, a gets cancelled, that is equal to 4 by 5. Now you substitute the values here, okay, to find the magnetic field at point P. Bp is equal to, okay, mu naught by 4 pi into I by a sin alpha, how much you got? 3 by 5, okay, plus of sin beta, how much you got? 4 by 5. 4 by 5, that is equal to mu naught by 4 pi into I by a, you can take 5 as LCM, 7, that is equal to 7 mu naught I divided by 4 5s are 20 pi. 7 mu naught I divided by 20 pi. This is the right answer. Hope you understood this sum. Okay, please remember this formula to calculate the magnetic field at point P due to a straight current carrying conductor. This is for what? Finite length. This is for what? Finite length. Finite length. Wire which is having finite length. Okay. Now let us see the next problem. Now magnetic field at P. You have to calculate magnetic field at P due to both infinite long currents carrying wires is how much? You are supposed to calculate the magnetic field. Okay. Now this is, I will call this as 1. Okay, this two wires. Okay, you have to calculate magnetic field at point P due to these two infinite long currents carrying wires. Okay. Now what is B1? See, if you use right hand thumb rule, okay, thumb pointing upwards, where the fingers are pointing, fingers are encircling into the plane of the paper. Okay, therefore B1 will be inside. B1 will be inside. What about for the second conductor? Again, the thumb pointing upwards, fingers are encircling into the plane of the paper. Okay, that is B2 is also will be inside itself. Therefore, B net, okay, net magnetic field will be what? B1 plus of B2. Okay, what is the formula for a magnetic field for an infinite long current carrying conductor? Okay, infinite long current carrying conductor, that is given by P is equal to, in general, that is given by mu naught by 4 pi into 2I by R. R is again what? Perpendicular distance. Okay. Now for first current carrying conductor, that is infinite, we see mu naught by 4 pi. Okay. 2. I will call this as I1. Okay. This is what? I2. I2 is how much? 2.5. Okay. 2 into 2 I1 by, let me call this as what? R1. R1 is how much? R1 is equal to, I1 is how much? I1 is 5 amperes. Okay. How much is R1? Perpendicular distance, that is from P to 5 plus 2.5, that is equal to 7.5 meter. Right. Okay. Now similarly for I2, for the second current carrying conductor which is infinite, I2 is equal to 2.5 amperes. How much is R2? R2 is equal to how much? This distance. Okay, 2.5. Now let us, okay, B2 is equal to how much? B2 is equal to mu naught by 4 pi into 2I2 by R2. Okay. Now which is common? I can take, if I write Bn, I can take mu naught by 4 pi into 2, I can take common, into what? I1 by R1 plus I2 by R2 into B R2. That is equal to mu naught into 2 divided by 4 pi much is I1? I1 is 5 divided by how much is R1? 7.5 plus of how much is I2? I2 is 2.5 divided by how much is R2? 2.5. Okay. That is equal to B net. B net will be equal to this 2, we are getting mu naught by 2 pi into 5. I can write 7.5 as what? 15 by 2, right? Plus of 1, that is equal to mu naught by 2 pi 15 into 10 by 15 plus of 1. Okay, that is 2 5s are 10. That is equal to mu naught by 2 pi 2 by 3 plus 1. Right, that is equal to mu naught by 2 pi. I can take 3 as LCM. 2 plus 3, that is 5. Okay, that is 5 mu naught divided by 6 pi. Okay, and it will be into the plane of the board or into the plane of the paper inside. Okay, 5 mu naught divided by 6 pi. Hope you have understood. Don't think this one. Okay, this is wrong. This is the correct answer. Hope you have understood. 5 mu naught divided by 6 pi. Let us see the next problem. The next problem, what it is saying, two parallel wires carrying current I and 2I. Okay, two parallel wires. Okay. Current I. I am now infinite long wire selection. Okay. 2I. In same direction, the magnetic field at the mid point between them. Okay. Here, magnetic field. Let us say point P. Okay. Now, see here. Due to this first current carrying conductor, let me call this a second current carrying conductor. Understood? Now, I have assumed what? Long wire, that is infinite, long, infinitely long current carrying conductor. Right? Okay. This is one. Now, if you point your thumb upwards, where the fingers will be, encircling will be inside. Therefore, this is B1 will be inside. B1 will be inside. What about this one? If you point thumb upwards, where the fingers will be, the palm will be on the left side and the fingers will be pointing out of the plane of the board. Okay, that is, this is B2. Right. Therefore, what about B1? B1 is equal to, you know that mu naught by 4 pi 2I1 by R1. I'll assume, okay, the distance is R. Okay, both are, so this is the midpoint. P is the midpoint. Okay, 2I1 by R. What about B2? B2 and this will be outside. What about B2? Mu naught by 4 pi 2I2 by R. 2I2 by R. Right. First we calculate P net. P net will be equal to what? This is what? This will be inside. Okay, that is equal to 1 10 2 2 4 mu naught by, this will be 2I2 by, so I1 is equal to I itself. Okay, therefore mu naught by 2 pi I by R. Okay, how much is I2? I2 is equal to how much here? I2 is equal to 2I. Therefore mu naught into 2 into 2, 4I divided by 4 pi r. 4 gets cancelled. That is equal to mu naught I divided by pi r. Okay, mu naught I divided by pi r. Which is greater? B2 is greater. Therefore, P net is equal to B2 minus of B1. See, mu naught by 2 pi into I by r. Mu naught by pi into I by r means which is greater. Here B2 is greater than B1. Therefore, I am subtracting. And where the net magnetic field will be outside itself. It will be outside. Pn will be outside itself. Understood? B2 is equal to how much? Mu naught I by pi r minus of mu naught by 2 pi I by r. That is equal to B net is equal to mu naught by r into I. 1 by pi minus of 1 by 2 pi. Right. That is equal to Bn is equal to how much is it? Mu naught I by r. I will take 2 pi as 2 minus of 1. That is equal to mu naught I divided by 2 pi r. We are getting Bn. Now in the second case, what is happening? If the current 2I is switched off, 2I is switched, we are making what in the second case? In the second case, we are making 2I is equal to 0. Okay. What happens? B net will be equal to how much? B net will be equal to B1 itself. That is equal to how much? How much was B1? Mu naught by 2 pi r into I. That is same as what? That is same as this one. So therefore, even if you, what happened? Let us say this as B. Okay. So this is also P. This is also B. Now, if the current 2 is switched off, the magnetic field at that point will be again B itself. Again, what? It will be B itself. There is no change. Okay. Net magnetic field will be B itself. Hope you understood this. We will do the next sum. What it is saying here, it is saying that infinitely long conductor PQR, okay, is bent to form a right angle as shown in figure. A current I flows PQR. Now, okay, PQ, this is I, okay, this is also I, they are saying QR, right? Okay. Now I can write what is H1 they have given. Magnetic field current is H1. Okay. What about now? The magnetic field due to this current at the point M is H1. What is H1? H1 is equal to magnetic field at M due to current in PQ. Okay. Infinite long conductor PQR is bent to form a right angle as shown in the figure. Current I flow through PQR. Okay, PQR. The magnetic field due to this current at the point M is. Now another infinite long straight conductor QS is connected at Q. Okay, so that current is I by 2. Okay, the next case what happens? This current will be I in the first case. In the second case, what happens? Magnetic field at M due to current in PQ plus magnetic field at M due to current in current in QR because same current flows here. But there will be no effect of this magnetic field at M due to QR will not be there. Okay, H1 is equal to just, let us say H1 is equal to what? H1 itself. Understood? They have given. Okay, magnetic field at M is due to because of this one only. In case of H2, H2, okay, in case of H2, what is happening? Magnetic field, magnetic field at M due to due to current in due to current in PQ plus magnetic field at M due to what? Due to QR plus magnetic field at M due to QS. See, in the very first case, this is H1. Magnetic field at M due to current in PQ will be H1 itself. Okay, there is no contribution of this one. Okay, magnetic field at M due to current in QR will not be there. Okay, that is 0. Okay, in the second case, what is happening? This current, what is happening? This current, okay, this current is getting divided into two current, that is I by 2, and this is also I by 2 in the second case. Now, at M, magnetic field at M due to current in PQ, okay, plus magnetic field at M due to current in QR. This again, this will not be there. Why? Because they are in the same, okay, this point is lying on the same current carrying conductor. What about magnetic field at M due to QS? Yeah, okay, here H2 will be equal to, what is magnetic field at M due to current in PQ? This is same. This is same as what? H1 itself. H1 plus of magnetic field at M due to QR will be 0, right? Now how much current will be flowing here? I2 will be flowing. Therefore, magnetic field at M due to QS will be half of what? RE. Okay, half of the magnetic field at M due to current in PQ. Now that is equal to H2 is equal to, add up these two, okay, 3 by 2 H1. Therefore, H1 by H2 is equal to 2 by 3. Hope you understood this, okay, 2 by 3. First, in the first case, current is flowing here, okay, current is flowing here, I, understood, current is flowing here, I, and current is flowing here, I. No contribution because of QR, because it is on the same, the point M is lying on the same straight current carrying conductor. And now here this is H1. Okay. In the second case, magnetic field at M due to current in PQ will be H1 itself. Okay, H1 itself plus 0 because of this QR plus half here for Q is half. Okay. Therefore, H1 by H2 is equal to 2 by 3. Students, hope you have enjoyed these problems. If you have liked this video, kindly share with your friends, subscribe for my channel, ask doubts in the comment box, and kindly like it if you have really liked it. I wish you all the best for your KCET and NEET examinations. Keep studying, get motivated. Thank you one and all for attending my online class.